In this lesson, we're continuing the work that we've been doing with linear functions. And we're going to start by learning a new form for the equation of a straight line. And we'll use it using the form that we used before. But we're finding the equation of a line that has a slope equal to m. Come on, pen. And has a y-intercept of b. And so that's the point 0, b. We'll use our point slope form that we looked at in the previous lesson. And we'll substitute in our slope and our y-intercept. So y minus b equals m times x minus 0. So once we add b to the other side of the equation, multiply through those brackets, we end up with y equals mx plus b. This is called slope-intercept form. And it's one of the quickest ways to graph a straight line, where your slope is given by m there, and your y-intercept is given by b. Sorry, y-intercept. So we're going to practice that. This will graph any non-vertical line using the method that we're looking at. And think also of it in terms of function format, where f at x equals mx plus b. Same thing. Very easy to graph this way. So rather than creating a table of values, which would be the old school way of doing it, we can look at this as our y-intercept. So our b is -4. And our slope is 2/3. So to graph that, it just takes a couple of steps. You start with graphing your y-intercept. So there's a point. At that point, y is -4 whenever x is 0, okay? And now our slope is 2/3. Remember, slope is rise over run. So I'm going to go up 2 over 3 and put in another point. And I can do that again if I've got the space. I can go up 2 over 3, up 2 over 3, and then using a ruler, which is tricky on a whiteboard, I can draw a straight line through those points, and I've graphed that line. Okay, so if we think about the steps, is plot the y-intercept, and then from that point, use the fact that slope is rise over run to graph more points. Technically, for a straight line, you only need 2 points, but it's often easier if you've got 3 or 4 points lined up. It's easier to make a more precise line. So let's take a look at this next one. Y equals -3/4 x plus 2. So our y-intercept is equal to 2. So we can plot that point. Our slope is -3/4. This is what I want you to do when you encounter a negative slope. Recall from the previous lesson that a negative slope means that it's a decreasing function as we move from left to right. So think of that negative as going with the rise and not the run. So always work to the right. So I'm going down 3 and to the right 4. And that way I get my negative slope done nicely. So down 3 and -4 more, and I've got another point, and I can join those points in a nice straight line, and I've got an accurate line. Okay, so negative slope means that I'm decreasing the y values as the x values increase. So I want to look at a couple of special cases. If you look at question 3, we've got y equals -3. There's no x showing, so one way to think of that equation would be as y equals 0 x's minus 3. So if I have 0 x's, that would mean my slope is 0 and my y-intercept is -3. So remember also from last class that a slope of 0 means that I've got a horizontal line. So a horizontal line would be just a horizontal line through the point -3. Okay? The other way to think about it is no matter what x is, y is negative 3. So for every value of x, y is negative 3. So I could plot a whole bunch of points along where y is negative 3 and join those points up. So horizontal when it's y equals some number, and we'll call it b because it will be the y-intercept, okay? The next special case, and I'll just do it on the same graph, is when we have x equals some number. So this does not fit in the format of y equals mx plus b at all because there's no y in the equation. What this means that for every value of y, x is equal to 2. So if you think about x being equal to 2 for all values of y, well, that would be all these points along here. And that gives us a vertical line. Okay? So it's a vertical line where we have an x-intercept equal to 2. Okay? So if you think about vertical lines always have the format of this equation, x equals a, or x equals something. So a quick question for you. Are horizontal lines functions? And we could say that they are because for every x there's only one y, and it's actually a constant function. It's constant over the whole domain. Are vertical lines functions? They're linear, they're nice and straight, but they're not functions because they don't pass the vertical line test, because for each value of x, you can have an undefined number of y values, okay? So it's not a function. All right, so this is actually the third form of the equation of a line, is the general form for an equation of a line. And what that form does is it moves everything to the left of the equal sign with the equal sign and then equals 0. So we have ax plus by plus c equals 0. A, b, and c are real numbers. And a and b are not both 0. That means one can be 0, but or the other, but not both can be 0. So we're going to look at how to graph those lines, okay? And all lines, including horizontal and vertical, can be written in this format. So works for all lines, including horizontal and vertical. Okay, and also any equation in this format can be rearranged into that y equals mx plus b format, so our slope-intercept format for easy graphing. Okay, so if I look at this first example, example 1, I've got 5x minus 2y minus 6 equals 0. So I'm going to rearrange that into y equals mx plus b format. So 5x minus 2y minus 6 equals 0. So I'll leave that negative 2y on the left side of the equal sign. I'll subtract 5x from both sides and add 6. So I've got negative 2y equals negative 5x plus 6. I want to get 1y, so I'll divide everything by negative 2. So now I have 1y equals, that becomes positive, 5 over 2x, and always leave that in fraction form for graphing because it's much easier to think of rise over run with in fraction form than it is in decimal form. And then we've got 6 over negative 2, so minus 3. So there's our y-intercept, there's our slope, we can graph that line. Negative 3 and then up 5 over 2. 1, 2, 3, 4, 5 and over 2, and I've got space to do that once more. And there is line 1. Okay. So let's take a look at the second example. We can do the same thing. Again, here's a really good time to press pause, try it, and then check it, okay? So I'm going to leave only the y term on the left side of the equal sign. So 7y equals, I'll have to subtract the 3x, add the 14, and then I need to divide every term by 7 to get 1y. So I've got y equals negative 3/7 x plus 2. So my y-intercept is 2, and my slope is negative 3/7, so down 3 and over 7. There's a second point, and I sketch my line through that. And please, on anything that needs to be marked, use a straight edge for those. Okay? So there's one other quick way to graph a line, and that's using intercepts. And that works also nicely with this general form for the equation. So if you think about what the intercepts mean, the x-intercept occurs when y is equal to 0. And the y-intercept occurs when x equals 0. If you think about that on the graph, you can see that. Did I leave a graph to sketch this on? No, so I'm going to sketch that without an actual graph. So here's my equation, 3x minus 6y. Oh, and that should be a plus 12 equals 0. Plus 12, yes. Okay, so let's find the y-intercept first. Okay, so the y-intercept happens when x is 0, so I end up with a 3 times 0 there. So I end up with just negative 6y plus 12 equals 0. Let's get the y by itself. So I've got negative 6y equals negative 12. So positive 6y will be positive 2. So my y-intercept is 2. So there's a point of that graph, the y-intercept. Now to get the x-intercept, my y-coordinate is equal to 0. So this middle term will drop out. This negative 6y will drop right out because it's equal to 0. So I'll have 3x plus 12 equals 0. So subtract 12 from both sides. So 3x equals negative 12. Divide both sides by 3, and x will be negative 4. So my x-intercept is negative 4. So 1, 2, 3, 4. There's that point, and I can join my two intercepts, and I've got that line sketched. So for the general form, using intercepts is also a quick way to graph a straight line. And that's it for this lesson.